Hello everyone, welcome. In this session, we will go through our first machine learning application and create our first model. In this process, we will introduce some core concepts. So before building any machine learning algorithms, so you need to understand that you need to know some basic terms. So the first thing is that what is machine learning. So basically machine learning is the ability of a machine to learn from data without being explicitly programmed. And in machine learning we have two type of problems. So we have classification problems and regression problems. And classification problems is where we have to predict a binary classification means an output which can be true or false, or means categorical data we have to predict, or binary. And in regression problem we have to, it means if it's a continuous data we have to predict a continuous data, which is a continuous data means the data which is continuous within a range. For that, in this tutorial we will see how we use machine learning to predict the survival of a patient with heart failure. So the dataset is available and it is a free data. To get the data, I will put the link on the description below, so you can also see. You can just Google it. You just need to say UCL and machine learning repository. So this is the URL. When you come to this URL, you will see the dataset here with all the description. And I think here is heart failure. This is the dataset, so you can come to this URL. I will put it on the description below. So this is the machine learning that I did. So this is basically a machine learning project, just small project that I did. So here I read the data set here using the read CSV, and I just use the head function to see the first 5 rows of my data set. And after that I just try to explain the data. Before building any machine learning algorithm, it is often a good idea to inspect your data to see if the task is easily solvable without any machine learning, or if it can be used or machine learning, or if the desired information might be containing the data you want. And one of the best way of inspecting your data is to visualize your data. So we will go through each step for building our machine learning. So the next thing that we did after reading our data set is to see the data type, because we need to understand what kind of data we are working with. So we used the type attribute to see the data type of our data set. So the next thing that we do, we try to see the data set, the data type with the non-null counts using the info function. And if it is telling us that it's a panda core data frame, our data set is a data frame already. So we use the describe function. Next is to see some statistical information about our data. So count means the number of recorded element in our data set, means the number of rows. Mean is the mean of each sample. For example, in this column age, the mean is 60.883, and for this column anemia, this is the 0.431 is the mean, and so on. And this is steady, means the standard deviation. This is the minimum. This is the first quartile. This is the third quartile. This is the third quartile range. This is the maximum value of, for each column the maximum value is given. And the next thing that is to see the shape of our data, to see exactly what which kind of data, if it is a big data, a large data or not. So we can see that we have 299 rows and 13 columns. and then we use to the column attribute to see all the columns that we have in our data set, and then this we pass it to this to list to just get it as a list. Otherwise it will give us as a series of index, so this is not what we want it to. For it to look nice, we just use this to list function. And then the next thing is we try to rename this date event by target, because as you can see here from our original data, let me just go back here and show you. So this is what we are trying to predict. This is the date event. So 1 means the person will survive, 0 means the person will die. The description is here, so when you go to the data set, you will see all the description of the data set. So let me go back to here, and what we did is that we could see that from our columns that everything is in lowercase, so only this one is in uppercase. So we try to change this uppercase to lowercase, and because this is our target variable, we just name it as target. We use the rename function and the in place to replace it from our original data set. And then after that we try to see the first five rows of our target variable. And after that we try to check, we just check if we have any missing data, missing values in our data set using the null function and the sum. If we use only the null function, it will return a boolean true or false, but here we don't want to see that. It's very difficult to go through each row to see where it is true or false, so we use the sum function. It will find the sum of all null or non-null, and then it will return it. It's quite easy. Panda provide this one is a wonderful thing. And we try to see from target how many variable we have, because as I told you that in classification we have binary classification where you have to predict a true or false, yes or no. 2 variable means binary, and then when you have more than 2 variable, that is known as multi-class classification. And I will make a video using the IRS dataset where we have to use multi-class classification more than 2 class. And then what we did here is to visualize. As I told you that visualization is the best way to inspect our data. So we try to see we try to see how many count we have for each of the target variable. For 0 we have 200, and then for 1 we have around 100, so you can see here from our visualization. And then we try to find we went to see the age, and the age we can see that the minimum age is 40 and the maximum age is 95. The average age is 60. So after that we use bar plot for the age by using the target variable, and then after that we try to see the age distribution, how data is. So we just find it here, and after that we use this plot to see how the age is distributed, because we are interested to know more about our data. And after that we find we use count plot to see which gender has more risk. So we can see here the count plot, we use the hue as the target, so we can see here that the means the male mean 1, 0 mean female. So we can see that the percentage of male that will die is very high as compared to female. And also we just try to inspect the smoking variable, and then we just try to use it also to see how it is, but in this case the female is higher than the male. And then we can see that the number of people who smoke is more than the number of women who smoke is more than the men. So it's really strange. In this case also we use it, and the same thing. And then from here we start building our machine learning model. We import from sklearn we import the trend test split, and then we use logistic regression and random forest classifier. So these are this is logistic regression. It's kind of you will think it's a regression problem, but basically it's a classification problem. It is used for predicting just binary classification, means 0 or 0 or 1 or yes or no, true or false, something like that. And then we try to do the future selection to select which variable to use as predictor, and then the target. So we use x, we use all the variable for predicting. Expect means I'm going to drop x won't be target, I'm sorry, target is not in our data in our x variable. So we use target here we only have target, and then we try to see x. From here you can see I have all the columns, but except target is not included here. And then I use the trend test split to split the data into training set and testing set. Means I need to this trend test split will shuffle the data and split it into training and testing. Basically it's 25% and 40% of training and testing, 20% of training and 8% of the 8% training and 20% testing. So I fit the model here, and after that I try to predict here, and then I got an accuracy of 85%. So that means our model does very good in predicting. And in this time I need to explain you this concept of confusion matrix. This is to check how to evaluate our model, to see how good our model is. Confusion matrix is used for it. And then you have to understand that because we are having a binary classification, so it means we will get a 2 by 2 matrix. If it was multi-class classification, it will depend on the variable. If we have 3 variables, we will have a 3 by 3 matrix. If it is 4 by 4 matrix, it depends on the number of classes we have to predict on. So this is means 13 means the true positive, and this is the true negative. And we can see that our model does very good prediction, and this is the false positive and this is the false negative. So I will explain this one in more in the next cell. So in this cell what we did, we try to print it and we see the accuracy, and that's good. So the result tell us that we have 13 plus 4 correct prediction, means this is true positive, this is false negative, false positive. So these are the things that means our model does very good. And then you always need to understand that to check if our model is good, if if the first means the zeroth very number, and this one is very high, then from the diagonal element, if those elements are very higher than others, it means our model does good. And this is basically and then I try to use the classification report to see exactly some of the most important concepts that we need to use also for checking the accuracy to evaluate our model. And this is the classification report. What classification report will do, it will tell us more about the precision, the record, the F1 score. So basically the precision is basically the true positive, the ratio of true positive by the true positive plus the false positive. So in this case we have this is the true positive, and then we divided by and then we divided by the true positive by this one also, and then by the false negative by 4 also. So this will give us this precision. And then for record also we have the true positive, it's the ratio of true positive divided by true positive plus the false negative. And then we have to understand that precision is intuitively the ability of a classifier to not label the sample as positive that's supposed to be negative. Means you have it, if it's supposed to be positive, and then the classifier will classify it as negative, so this means it's not good. And this means our model does good because it's 80%, means it classifies very well 80% of our data, and then for the remaining it doesn't classify it as good. So this is basic 88, I mean, because we have to look at the weighted average. So 88% is well classified. And then for the recall also, for the recall also, we can see that this is it will find only all the positive sample. It will find, it is an intuitive the ability of the classifier to find all positive sample, all positive sample. And we can see that the all positive sample for this classifier is 0.85. And then F1 score also, it's just a weighted harmonic mean of the precision and the recall. So this is basically, I just try to describe it here, and after that I try to use something that we also use to check the accuracy of our model, which is the which is basically are the ROC curve. And then I just try to plot it using the matrix function. I import matrix at ROC and then ROC curve, and then I just try to plot it, and it is showing how the model is. And the good one is where that this blue line has to stay away from our this red line. It means our model is good, but when it is close, it means the model is very bad. So here the model is good at least, but not the best one. And then we introduced to random forest classifier, and then we did the same thing. We just split the data into training and testing, but here we use 25% of testing and 75% of the data for training the model. And then we fit it here, and then we predict, and then we got an accuracy of 90, so which is pretty good. It is better than the other one. And then we can see that the true positive 52, and the false negative is 60. And then we try to do the same thing, the classification report, and then we find the precision. We can see here we predict correctly, 91% is predicted correctly, and the recall also was 99, and the F1 score also was 99. So it means here that this model is better than the first one. Means in this kind of problem, means random forest classifier is more suitable for solving this kind of problem. So and then here you can see, as I try to plot this ROC curve, it directly staying far away from this blue line. So, and then I try to compare the model, and this is what I got. And you can see the other one was 90, the other one was the logistic regression was 85, and the random forest was 90. So in conclusion, we can conclude that the random forest classifier is preferable for solving this kind of problem. And I hope you guys will enjoy this tutorial, and I will put the link to the code on the description below, and also the link to the dataset. Thanks for watching, and I just hope to see you in the next video.